On the West Coast, Oak Creek Energy Systems Incorporated is a pioneer in gigawatt-scale wind energy with its long-term expansion of wind power capacity in the Tehachapi-Mojave area of California.
With this project for Cal Portland Cement, we're making enough energy to reduce what they use from the utility, which in this case is Southern California Edison. We reduce the energy usage to zero on a windy day.
The design life of the projects is 20 years. The typical planned lifetime is from a financing standpoint, is 25, and the practical lifetime is something well beyond that. We're looking at 30, 40, 50 years, what we would expect the projects to be able to do. We use copper in the underground cable and bus bar, various applications. In fact, we just now have a new small interconnection facility we're designing, and we'll actually be putting some copper tubing in as the primary conductor instead of aluminum. In that case, primarily because of size characteristics and and corrosion issues. The risks of corrosion on copper joints are much lower than on aluminum joints. We use bare copper wire in every trench that's spread throughout the site. So you get them, all throughout the site over a broad area. And it's just amazing what that does. We're not immune to lightning strikes, but we get much, much less lightning damage than most wind parks get. Primarily, we feel that the bare copper in the ground and spread as wide as we have it sort of makes the whole wind park a ground plane. It's been extremely effective here, and not only do we have it through the ground, but then we tie in the foundations are heavily embedded with copper and to form very good ground deep into the ground. We go, like 35 feet in with the copper coils, and that all gives you down into the dry soil. You get into a more moist soil, and you get better grounding connections, and then tie it to the tower, and the tower forms a dissipator into the environment. So you have all of that tied together, and it's a heck of a lightning protection system. There's also a copper conductor in each blade, and it goes out at the end of the blade. There's a copper tit at each side, and then that's tied in to the tower and then tied into the grounding system.
Through the years, my experience has been that copper is the better product to use over aluminum. And the reason I feel that way is because the reliability of copper cable has been better. I mean, when I've had failures in the field on my high voltage systems, almost always it has been with an aluminum cable, not copper. There seems to be a lot less in the way of corrosion issues and shrinkage issues due to heat, so you don't have connectors loosening up as much. And when we have a failure at a connector, generally that's in a control panel that has a lot of expensive components in it. So if you pay a little bit more to connect that controller to the grid, cost of the cable is not the deciding issue. If you put a cable in and 5 years later the control panel burns up because you use cheaper cable, that's, in my opinion, it's penny wise and pound foolish. So you spend a little more money at the beginning and you end up having higher reliability, and you avoid the catastrophic panel failures that can knock a turbine off for days or sometimes months.
Not only does copper make economic sense, the whole concept of wind energy generation makes good sense for many companies, not only as an alternative, but as a primary supplier of electrical power.
The price of energy has been pretty volatile in the country and the world, really, for over the last 5 years, maybe 10 years even. The days of 3-cent electricity are long gone, at least in California. And these huge manufacturing facilities really, energy is a huge portion of their operating costs. So it's very important for them to keep costs down, and they're saving a significant amount over what they would have to pay if they were to buy that energy from the utility right now. So, they're not doing it only for the green benefit, though Cal Portland recognizes that benefit. This is a good economic decision. It's a way for them to isolate themselves from the fluctuations in the cost of energy due to things that are well beyond their control.
Just like the copper infrastructure that makes it run, it's sustainable, it's affordable, and it's profitable. You can call it a win-win-win strategy whose time has come.